So hi, in today's session we are going to do something organic sounding. I don't know what it will turn out yet, but I hope it will sound organic, or something that you believe that it comes from a physical instrument instead of some synthesis, because I think that's interesting. And for such things I usually convert the gate at the first second to some trigger, which is simply creating a change node and multiplying the change node with the gate itself, which means that we will only get one value whenever we press the button. Every other time the output will be 0, like on this scope. Get a frequency of 1, create a gain node. This is going to be our output. I mute it because this is not funny to hear. Connecting SEP, output 1, output 2, and if I hit a key, we have a burst, and if I release it, we have no burst because the change itself will create a burst even if I press a key and release it. So press, release, there's a burst. But we only want it when we just press a key. So for me, these organic kind of sounds or physical modeled sounds are mostly based on such methods. So what we can do with these bursts are more or less, for me at least, three things. We can create a string, and a string is something like a karplus prong. So we have a input, we have a pitch input, so I rename this to P, and we have a feedback input, and we feed the input into a delay and set the pitch of the delay according to the set the length of the delay according to the pitch. And since delays work in milliseconds, we have to convert the pitch to milliseconds, which is pretty simple. Let's convert it to hertz. And to get the wavelength, we have to take the reciprocal of the frequency, because that's the way things work. And now we have the wavelength in seconds. And to get the wavelength in milliseconds, we just have to divide the pitch, the frequency, with 1000 instead of 1. That's the same like multiplying the reciprocal with 1000, but this way it's cleaner and one multiplication less. So to create the feedback, we need to add something to the input, and we have to have a multiplication on the output and connect it to the head. Clean it up using the cone. And I usually put the output to this multiplication and connect the feedback to the output. So this is basically nothing more than a comb filter, but we can create damping in no time by inserting, let's say, a one-pole filter here. That's all. That's cool, and create an input for it. Let's call it DNP, like damping. So this is one thing we can do. I call this string. What the string does is pretty simple. We connect it up to here what we have, and I plug in the plug itself into the scope so we can see it. Connect the pitch, create a knob for the feedback, create a knob for the damping, like this, and set the feedback to something high between 0.9 and 1, and the damping between 0 and 128. And as we see, when I hit the key, we get a decaying sound. So, this is one method, but we can do something different with this plaque, like creating I still don't know what I should call this, because people usually call this also resonator, but I like to call something a resonator that's really doing some resonance thing, like a 2P filter. Add the name, and pitch, I convert the pitch to hertz. Now this will be the end. That's hertz to pitch, and now pitch to hertz. So we did nothing with the signal with these two things, but I will insert a multiplier here, and we'll create an input for the B, and here we are going to tell the frequency ratio. So this tells us how in hertz how much we will multiply the pitch frequency with. I don't know if this sentence made sense, but I hope it made. And there's the resonance, and I use the band output and connect the resonance and divide it, yeah, like that, and create the output. And this is another thing we can do, and I can connect this up to it. I can connect the pitch to the P, the ratio gets a knob, and the damping gets the same values. No, it's not damping, it's resonance, so it's between 0 and 1, but better 0.1 and 1, like this. And let's give this a listen, and this should be between 1 and, let's say, 16, and I set it to center, then step, and I don't see anything because it's not loud enough. So yeah, soon we will get back to this, but one more thing we can do with this kind of triggers and this burst, this small burst, to give it some release. Like, we can connect it to this envelope follower. Now I put this there, and if I play, we just have the burst. If I give this the release, you can see we have this nice fade out. And this helps me with this resonator thing, like this. Or maybe I didn't move this knob. Yeah. So as we can hear, the the output of this resonator is nothing more than a sine wave, but the decay time is dependent on the pitch and on the resonance. So if I set the resonance to something higher, it gets short. If I set it too low, it gets long. Same with the rate, and when I play it on a higher volume, the time of the fade out gets shorter. If I play it on a lower note, it gets longer. So it's pretty organic. It's not something that's constant and sounds nice. And with this ratio, all we can do is to set it to higher pitches. And this is good because we can connect this right into the string. So we can combine these methods. Excuse me, and listen to what we have got now. Something very loud. Maybe I don't even need that. Yeah, this is sounding nice. So we are starting with the resonator and going to the string without oscillators, without noise, without anything. This is just something that sound does. It resonates and decays. So I like this kind of synthesis because it's so close to something that we experience in our life, and I don't know if people use it this way. And we can make it a bit more interesting by, let's say, changing this feedback to something like a piano sustain, but I did this in another noding session. But I'm going to do this again. But first I clean this patch up, so I create something like a bus using these cone notes, and this will be my pitch bus. It's just a straight line that always goes into the pitch, and the patch looks a lot better. So now I create a crossfader. I plug the feedback into the one value, or the B value. The first one stays on 0, and the crossfade is going to be driven by the gate. And I clean it up, move it to the side, and now if I play the key and release it, the sound releases. I can smooth this crossfade by putting an envelope follower modulated there, and I even can I can show it on the scope because it's between 0 and 1, so it's pretty much fitting with the scope well. Drag this into the B. So you can see on the orange line what happens. That's the gate, basically, and yay. So what we can do, create another resonator, and since this resonator is not a sine oscillator, we can plug it also behind the string, and this way the string is going to be the source of the sound, if it makes sense. And let's use a different resonance, and let's see what this sounds like. This is not much of what I like, but if I crank this resonance up so it's not that long, yeah. And from here on we can create more of these resonators. Copy paste. This is the second one, third one. Let's create 4, because we can do as much as we like. And now 4 is the number I like. To the right, to the right, to the right, move to the side, and I connect the pitch. And I create another cone, and I will create a spider web now to the inputs. I don't like to do spider webs, but this is only for mods, so yeah, I create a mixer. Plug this into the second, into the third, and into the fourth input of the mixer. Change the ratios to whatever you like. Different resonance values are also welcome, and different gain levels. And if we hit a key now, okay, lower resonance, more feedback. A lot more feedback. And yeah, let's do something experimental. Not if this was not experimental, but let's add another burst here, which is going to be only active when we release the key. And that's pretty simple to do, because we have seen that multiplying the gate with a change node that's driven by the gate outputs one value when we hit the key. So to do the opposite, we need to subtract the gate from 1 and multiply it with the change. And this should be creating burst when I release the key. Yeah, you can see it on this orange line. That's where I release the key. Cool. And I'm going to give this an envelope. And I'm going to give this also, I'm going to add this to these resonators. Maybe I create a string for it and that, but this is going to be a different setting, so it's going to sound interesting, maybe. Feedback should be somewhere between 0.9. Yeah, this is going to really decay for a long time. And for the damping, yeah, this sounds like a pick when you release a key. And we are having pretty simple building blocks like delay, two-pole filter, and a delay. And for the sound source we only use the gate, and we only modify the gate and process it. And the output sounds organic and if we play with velocities and stuff like this, things can become pretty fast, nice sounding and natural sounding. So these are the basics of how I work with such sounds. Sometimes I use noise because noise is nice. Even this part could use a noise, and then it would be more different whenever you hit a key, but also this way you get a nice sound. So yeah, this is my basic workflow, and this is the way I think about sound. I hope you enjoyed this video. I'm going to upload this patch to our site, and we'll do a demo song which is going to be probably heard in the intro, and we'll upload that too. So yeah, I really hope you had fun. Please subscribe to this channel and share our videos, and do some noding and do some cool sounds. And if you have any suggestions of what I should do next, tell me. I wanna hear it and I wanna know it, and if you want me to clean up your patches, like to look this good, send me your patch and I'll be happy to do it. So thanks for watching guys, and happy noding, and bye bye.